All right, Miss Champion, 7th graders, welcome back. We are starting today with solving one-step inequalities. So on our numeracy here, it tells us that a closed circle means it includes the number, right? So those are our equal to symbols that we talked about yesterday. So you have a greater than or equal to, a less than or equal to. As long as it's equal to, that circle over there will be closed. When it is an open circle, it does not include the number. Those are not equal to. So you see that red dot. It is not closed. It is not equal to. So we have x is greater than 2. That's what the graph for that would look like. Open circle, arrow to the right, because all the numbers get greater than 2 to the right. And then for x is greater than or equal to 2 on the left here, we see that we have a closed circle on the 2 and then all the numbers going to the right. So it asks us, I think here it wants to see our graph for -8 is greater than x. So remember we talked about yesterday, we want to make sure that our variable is on the left. We're going to rewrite it so that variable comes first and our -8 would be on the right. That's going to make it easier for us to graph it. When I look here though, my alligator mouth, my symbol is opening up towards the 8, right? So I have to make sure that when I flip this around, I do not change the inequality and I make sure that it's still opening up towards the 8. So now when I go to graph that, I'm going to put my -8 on the graph. And then since it is a less than symbol, I have to have just an open circle. And where the number is less than -8, to the left. All right, so we're going to solve inequalities just like we solve equations. So we're going to use our inverse operations. With my first equation, this is something that we just took a test on in Module 6. We're going to draw our line, and we see c plus 4 equals 6. So the opposite of addition, we know, is subtraction. If I do 4 minus 4, that equals 0. Whatever I do to one side, I have to do it to the other side to keep it balanced. 6 minus 4 is 2. So that's how I solve the equation, right? When I solve an inequality, I'm going to do the same thing. I'm going to draw my line down the middle wherever my symbol is. When I see plus 4, instead I'm going to use minus 4. And instead of having c equals 2, I'm going to get c is greater than 2. And then we would graph that. So we're going to practice that today using all of our inverse operations that we learned about last module. So first, number 3, 7x is greater than 21. So think to yourself, 7x, what does that mean? What operation is that? That is multiplication, right? So the opposite of multiplication, I have to divide by 7, right? So we divide by 7 on both sides. And we get x is greater than 21 divided by 7. Put it in your calculator. You should get 3. X is greater than 3. So now the added step that we have to follow here is to put it on our graph. So we'll put 3 on our graph. I see that it is a greater than symbol, so that means my circle has to be open because it's not equal. It does not include 3. And the numbers are greater than 3 to the right. Number 4, I have 12 is greater than x minus 4. So I'm going to follow my same steps to solve this, even though my variable is on the wrong side. We'll deal with that at the end. So I have x minus 4. What is the opposite of subtraction? Addition. So we're going to add 4 to both sides. And -4 plus 4 is 0. That's why we cross it off. And we get x on this side. Our symbol stays the exact same. 12 plus 4, we get 16. All right, so like I said before, we want to rewrite it so our variable is on the left and our constant is on the right. If I look here, my symbol is opening up to the 16. So I'm going to make sure that when I rewrite it, my symbol is opening up to the 16. So when I read this now, it says that x is less than 16. So let's go ahead. Let's put 16 on our graph. It's not equal to, so we still have an open circle. But since it is less than, now we have to draw our arrow to the left. All right, so we have here m divided by 3 is less than or equal to -2. So what is the opposite of division? We're going to multiply each side by 3. Be careful with your negative. M is less than or equal to -2 times 3 gives us -6. All right, let's put -6 on our graph. Now we do, oh, what did I just do? Okay, now we do have our equal to, right? So my equal to tells me that I'm going to have a closed circle. I'm including -6. M is less than it, though. So where do the numbers get smaller than -6? To the left. Okay, flip it over. And let's move on to the back. We got 2 more problems. We're going to circle the values of y that satisfy the inequality below. So what that means is first we got to solve for y. We have to get y by itself. And then we're going to pick numbers that would actually make the statement true if I substituted them in for y. So let's actually show what does that mean. Start by solving. We draw our line. I've got y divided by 3 is greater than or equal to 15. So this is where our inverse operations are really important. We want to make sure that we know how to solve these. The opposite of division is multiplication. So we're going to multiply each side by 3. And we're going to get y is greater than or equal to 15 times 3 gives us 45. So greater than or equal to 45. So now I look at these numbers, A, B, C, D, E, F, G. Are they greater than or equal to 45? So let's say if I put in 45, we're testing if I can put any of these numbers in for y. So I'm just going to go ahead and draw the inequalities. Is -45 greater than or equal to 45? No, right? It's much less than because it's a negative number. Is 0 greater than or equal to 45? Nope. Is 8 greater than or equal to 45? Nope. Is 43 greater than or equal to 45? Nope. Now, you may not need to have to write an inequality for every single one of these, but I'm just going to show you to make sure we're all clear and we're all on the same page. All right. So is 45 greater than or equal to 45? Yeah, right, because we have that equal to. That equal to tells us to. Is 52 greater than or equal to 45? It sure is. And is 58 greater than or equal to 45? Yes, these are both greater. So we would have E, F, and G. Okay, last one is we are matching our inequalities to the graphs connected to the graphs. We're going to draw lines. All right, so I have n is less than or equal to -5. So one thing I always like to look at and teach is like a test taking skill, right? So if A has a -5, I'm going to look at which graph just already starts with -5 on it, right? Like I'm not going to pick the first graph because that has a 2. That wouldn't make any sense. So by doing that, I've already eliminated all of the other options. We do want to note that this has a greater or less than or equal to symbol. So that means our circle should be closed. So that already gets rid of this one and this one for me as well. And it shows where it's less than. So we know numbers are less than to the left. So we have graph 3 for letter A. For graph B, we have less than or equal to 2. So again, my less than or equal tells me that I have to have a closed circle. So there's only one other option that has a closed circle. It also does start on 2, and it goes to the left. All right, we have C is less than 5. So if I look at this graph right here, that shows greater than 1, right? So I cannot use graph 2, and that's where I get graph 4 because it starts on 5, it has that open circle, and it goes to the left. Which means our last one is going to be P is greater than 1. So again, I'm going to have an open circle, and it's showing where the numbers get greater, which is to the right. All right, that is it for today, day 2, solving inequalities. As I said earlier, make sure you're just solving them using your inverse operations like normal. and then making sure we put them on our graph. If you have any questions, make sure you just put them in your classroom. I can answer them or Miss Champion can answer them. I don't think I told